Power plant, fuel system. Objectives. After completing this section you will get familiar with fuel tanks, fuel distribution system, fuel pumps, emergency fuel valve, and fuel temperature and fuel grade. Fuel tanks. DA40NG is equipped with two fuel tanks. The main tank and the auxiliary tank. The main fuel tank is located on the left wing, whereas the auxiliary fuel tank is located on the right wing. Long-range tank can be installed to increase the fuel capacity of the airplane. The main fuel tank is made of an aluminum chamber and a filler tube. They are connected by a flexible hose. There are two vents on the main tank. One for a check valve with a capillary, and the other for a pressure relief valve. The check valve with capillary acts as a one-way valve, allowing the air to enter the tank, and preventing the fuel from flowing out. The capillary equalizes the air pressure during the climb. The pressure relief valve operates at 150 millibar, and relieves any excessive pressure in the tank. The hose endings are on the underside of the wing, approximately 2 meters from the wing tip. The auxiliary fuel tank is similar in construction to the main tank. It has an aluminum chamber and a filler tube. They are connected by a flexible hose. There are two vents on the auxiliary tank. One vent has a check valve with capillary, and the other one has only a capillary. The check valve acts as a one-way valve during the descent, and allows the air inside the tank, and stops the fuel from flowing out. The second capillary is installed for additional safety. A long-range tank is an additional tank to provide increased fuel capacity for the airplane. It can be installed in both main and auxiliary tanks, in place of the filler tubes. Each chamber of a long-range tank has a capacity of approximately 5 US gallons. The ventilation system of the main and auxiliary tanks remains unchanged with the long-range tank installation. The fuel quantity of the tanks is shown. The usable capacity of each tank is 14 US gallons, and 19.5 US gallons with an additional long-range tank. However, the fuel quantity indicator can indicate a maximum of 14 US gallons. Fuel levels above 14 gallons are not indicated. When the indicator reads 0, only unusable fuel remains in the tank. The maximum permissible difference between the right and the left tank is 9 US gallons. Note: when the fuel quantity indicator reads 14 US gallons, the correct fuel quantity must be determined with the alternate mean for fuel quantity indication. If this measurement is not carried out, the fuel quantity available for flight planning is 14 US gallons. Fuel distribution system. A few important components in the fuel system are course filter, gascolator, fuel cooler, capacity probe, and alternate fuel quantity indicator. The course filters, also known as finger filters, are used to trap the contaminants attempting to flow out of the tank to the fuel system. They are fitted before the tank outlet. A gascolator has a drain valve that can be used to remove the water and sediments collected in the fuel system. It is located at the lowest point of the fuel system, at the center of the fuselage underside, approximately 30 centimeters forward of the wing leading edge. The fuel cooler is located in the right-hand wing stub, between the wing spars. It is responsible for cooling the fuel temperature between the auxiliary tank and the main tank. The air flowing through the air scoop, on the lower surface of the stub wing is directed over the fuel cooler. The air inlet to the tanks is closed with a baffle. In case of outside air temperatures higher than 20 degrees Celsius, the baffle must be removed from the inlet. The fuel quantity is measured in each tank using a capacity probe, and is displayed on engine display and counts. The indications are nonlinear. Hence, a pilot cannot proportionally calculate the remaining fuel quantity, or the fuel quantity that is consumed. Another means for fuel quantity indication is by a device that allows measurement of the fuel quantity on the ground during the pre-flight inspection. It has two parts. The first part, with the recess, fits the airfoil of the wing. It is held against the stall strip, at the leading edge of the wing. The second part is the metal connector, that is pressed against the drain valve of the tank, under the wing. By the principle of communicating containers, the fuel level is indicated on the vertical ascending pipe. For the long-range tanks, the indicator has additional markings. Note: for an exact fuel quantity indication, the airplane must stand on level ground. The designated place for the fuel quantity measuring device is the bag, on the rear side of the pilot seat. Fuel pumps. The fuel from the tanks is supplied to the engine by two parallel installed independent, low-pressure, electrically driven fuel pumps. One of the two fuel pumps works during normal operation. The ECU switches automatically to the second fuel pump in case of low fuel pressure. Both the fuel pumps are connected electrically to an ECU bus and protected by a 7.5 ampere circuit breaker. The fuel pumps can be both activated manually by the fuel pump switch during the takeoff, landing, or in case of low fuel pressure. The fuel pump switch is located on the instrument panel. If it is set to on, both fuel pumps are activated, and the fuel pressure increases. Note: by switching between ECU A and B, the two independent electrical fuel pumps are switched over as well. In case of an emergency, both pumps can be activated simultaneously by pushing the fuel pump switch to the on position. During normal fuel transfer, the fuel is drawn by the fuel pump from the main tank and passed through the emergency fuel valve. Each engine cylinder has one fuel injection nozzle. A low-pressure pump and a high-pressure pump are powered mechanically by the engine. These pumps regulate the pressure inside the rail and ensure fuel supply into the cylinder. The fuel that is not injected into cylinders is sent back into the main tank through the auxiliary tank. Such a system cools down the fuel temperature in the rails and keeps the fuel in the tanks at optimum temperature. The fuel transfer between the auxiliary tank and the main tank is possible with the help of an electric transfer pump. If the main tank is full, or the auxiliary tank is empty, the transfer switch is automatically switched off. The emergency fuel supply comes into operation if the fuel transfer is not possible for any reason. In this case, the fuel is supplied to the cylinders directly from the auxiliary tank. The fuel will be transferred from the right tank to the left tank via the return line. Emergency fuel valve. The emergency fuel valve handle is located on the center console. A long shaft connects the control lever to the valve, which is located under the cockpit floor. It is a three-way valve with normal, emergency, and off positions. To turn the valve handle, the safety lock has to be lifted. The safety lock is to ensure that the position of the valve is not selected unintentionally. If the control lever is set to the normal, then the fuel is supplied from the main tank on the left wing. If the control lever is set to emergency, then the fuel is supplied from the auxiliary tank on the right wing. If the lever is set to off position, then no fuel is supplied. Caution: switching the fuel valve to the emergency transfer position will start the transferring of fuel, with the help of the engine-driven fuel pumps from the auxiliary tank, through the fuel return line to the main tank, at a rate of approximately 45 US gallons per hour, with the help of fuel pump switch in off position. The fuel valve must be switched back to the normal position before the auxiliary tank indication reads 0. If the fuel valve is not switched back to the normal position, the engine will stop running as soon as the auxiliary tank is empty. Fuel temperature and fuel grade. The fuel temperatures are indicated on the multifunction display. The maximum operating fuel temperature is plus 60 degrees Celsius, and the minimum is minus 25 degrees Celsius. The fuel grades, recommended for optimum performance of the airplane, are listed. It is mandatory the pilot is aware of the fuel grade in the tank before flying. For cold weather operations, anti-icing fluids is permitted. Caution: the use of PRIST high flash fuel additive is only permitted with Jet A, Jet A1, and JP8. Note: in order to provide information about the fuel grade, it is recommended to enter the fuel grade in the airplane log each time fuel is refilled. Summary: with this section, you got familiar with fuel tanks, fuel distribution system, fuel pumps, emergency fuel valve, and fuel temperature and fuel grade.